Just imagine this. You're hiking on a clear day. The weather looks good enough when you start hiking. But when you reach the summit, the weather suddenly changes and leaving you exposed to the thunderstorm without any warning. But with Flash B, you no longer have to rely on the guesswork. You can keep it on your backpack or clip it on your gear, and it will continuously monitor the lightning activity in your vicinity. If a storm begins to form nearby, the device will detect the lightning strike in real time and indicate the distance from you. On the display, the user can view the distance of the lightning strike as well as the strike energy indicator and a strike counter. And most importantly, there is a strike energy history feature. With this energy history, the user can determine if the thunderstorm is approaching. So let's get into some technical details. FlashP utilizes a grow lighting sensor AS3935, a specialized chip designed to detect the electromagnetic signature of lightning and estimate the distance and the strength of the strike using special algorithm. The sensor can detect lightning activity up to 40 kilometers away with an accuracy of 1 kilometer. To display this data to the user, we are using round display for XIAO and paired it with XIAO ESP32C3 from C Studio. So let's get into the build. I designed the enclosure on Fusion 360 and 3D printed it in yellow and black PLA. So we got all the parts that we actually needed. So let's start the assembly process. You can find all of the STL files as well as the code and the building guide on my instructables page, link in the description. Now just sit back and enjoy the assembly montage. So we are done with the build. Now we can actually connect the device on your PC and flash the firmware using Arduino IDE. Now we got everything working. It is time to put the device onto the test. However, we have a problem. There is currently no thunderstorm near my location to test this device. During the development of the device, we had a suitable weather condition, and I obtained some reliable reading from the sensor on my serial monitor. Because of that, I am confident that the device will work fine. Still, there is a way to test this device using a gas lighter. Simply place the lighter near the antenna and strike it. We should see a reading less than 1 kilometer on our device. This is how we test the device over the desk. I will be posting more outdoor test results and an updated version of the firmware in upcoming days. So stay tuned on my blog for more updates. I hope you like this project and stay safe and happy making.